For number 15, we're doing continuously compounded interest, and if you click on Help Me Solve This, you can be reminded of the formula for that. We're going to plug these values into the continuously compounded interest formula. And so we have our value for P, the principal. E is an irrational number, which means the decimal never stops. It goes on forever. It starts out at 2.718 and then just keeps going on and on forever. A calculator has a good approximation to the value of E, so use a calculator when doing continuously compound interest formula and use the E key on your calculator. And then we have the interest rate and the time in years up here in the exponent. So I reduced that exponent down first, so here's our exponent reduced. Those things multiplied together. And then I just calculated E to that exponent right here in Excel. You type in equals EXP, and then in parentheses you just type in what that exponent is. So that's the formula for E to raised to an exponent. So then you have 2,000 times that number, and there's your final answer for the amount. For number 16, it is a continuously compounded interest problem. We're going to plug these values into the formula. So we're given the amount, we don't know the principal. E is a constant number. And up in the exponent we have the interest rate and the time in years. Multiply those together to reduce the exponent. And then calculate E raised to that exponent. I did that right here in Excel. And then to solve for the principal, divide both sides by this number, and here is what the principal is. For number 17, we're dealing with continuously compounded interest, and here's the values we'll plug into the formula. So our value for A, for P, and for R, and we're solving for T. Divide both sides by this value to get to here. And our unknown value is up in the exponent, which means we need to use logarithms. And since our base is the number E, we'll use the natural log and do the log on both sides here. Got to do the same thing to both sides. And when you do it on this side, you can, the natural log and the E raised to an exponent, those cancel out, so you're just left with what the exponent is. And over here, use a calculator to get this value. And now to solve for T, you just need to divide by 0.075, and there's your answer. And if you're using Excel to do the natural log of a number, you just type in ln, you put an equal sign in front of that. So the natural log of whatever your value is inside, and it'll return what the natural log is of that number. For 18, we have continuously compounded interest. We're going to plug the values given here into the formula. So our principal 7,000, interest rate in 3 years. So reduce the exponent, multiply those together. We have E raised to the 0.24 power. Use a calculator or Excel to figure out what that is. And then the amount is going to be the principal times that value, and there's your answer. For number 19, we're dealing with compounded interest. So we have our formula here. We need to solve for I. And so it's the interest rate for the year divided by how many times interest is compounded throughout the year. And semi-annually is twice a year. So solve for I here. And then N is the number of total times interest is compounded. So if we want to compound for 5 years and we're compounding twice a year, that's going to be 10 total times. So the question states we want to have $15,000. We want that to be our amount. We're figuring out how much we should invest now if we are getting compounded interest at 5% semi-annual. So we use our values for I and for N here. And so the value in parentheses raised to the exponent, solve for that. And then to get P, divide both sides by that number. And here's the value you should invest to have $15,000 in 5 years. Now, if you want to have $15,000 in 10 years, this value for I is not going to change because our interest rate's the same. It's still semi-annual, which is twice a year. But over here, instead of 5 years, we're going to be compounding for 10 years. So that gives us 20 total times we're compounding. So that's the value that changes. And here, we're going to just change our exponent to a 20. So the part in parentheses raised to the exponent, we get this value now. So you get this value for the parentheses to the exponent, and then to solve for p, divide both sides by that number. And here's the amount you would have to initially invest to have $15,000 in 10 years.